Welcome you all to the Research Spark YouTube channel. So here we are going to talk about the course analog and the linear electronic circuits. So currently we are running in the unit second, that is the introduction to linear ICs, and this is the part third of our unit second. So in this session we are mostly going to talk about the ideal operational amplifier, followed by the IC741 package and the characteristics of operational amplifier. So first, what comes in your mind when we are using the word operational amplifier, that is OPMP. So the primary objective is to design the operational amplifier to amplify the any input signal. Any input signals may be the AC signals like sinusoidal, the rectangular, or any type of input. So here you can see in the right side there is the graph which contains the green color signals and the red color signals. So green color signal is the input voltage and the red color is output. So you can see the now amplitude of the green color is lesser compared to the amplitude of the red color. So red color is amplified one. How can we represent it? So the representation of the operational amplifiers can be shown here in the left side. It's a triangle because it have the two inputs and the one output. So triangle which can have the minus and the plus. Minus and plus are the representing the inverting terminal and the non-inverting terminal, and the pin third which is showing the V out, that is being used to collect the output. So this is actually the primary objective to design the operational amplifier. Now, let's talk about some ideal operational parameters. So, first thing is that the internal differential gain, that is the AOAD, is considered to be infinity. Means our operational amplifier have the almost infinity gain, means very high gain, almost in the range of the 10 to the power 6. The differential input voltage in between the V2 and V1, that is almost to be 0, and that is why AOD is very large. And if the input voltage average V out is finite, then the two input voltage must be nearly equal. So the internal resistance in between the minus and plus, that will be the infinity. So this is the one of the ideal characteristics. So why is it so? Because if the resistance is infinity in between the minus and plus, then no current will flow through the operational amplifier. So in short, the summary is that just remember the three things, that is ideal parameters. So the first is the gain should be infinity. Second, the input resistance, that is impedance in between the minus and plus, it should be the very high or infinity, and the output resistance is almost 0. So this is the IC741 package. Here you can see the IC741 contains the 8 pins. 8 pins means it have the 1 2 3 4. Here pin numbers 2 and 3 is being used to provide the input signal, and pin number 6 is being used to collect the output signal, that is the amplified signal. And the pin number 4 and pin number 7 is being used to provide the the DC power, that is VCC, and the plus and minus. So here you can see the input signals, whatever we are supplying through the inputs, that is the R in, that is inverting terminal, and we are getting the correspondingly the output signal. Behind this operational amplifier, that is IC741, you can see the actual circuit diagram of the IC741. So here the only thing is that it contains the mostly transistor, that is BJT based circuits. So first stage is differential amplifier, then high gain and voltage amplifier, and the low impedance output amplifier. So these are the stages of the operational amplifier, that is IC741. So in short, IC741 is nothing the combination of the transistor amplifier. Practically specifications like if are we supplying the input voltage through the minus terminal, that is the non-inverting terminal, then we'll get the output with the the minus, that is the gain will be the minus R2 by R1. Minus is just representing the phase difference, that is phase difference of 180, because that is why this is called the inverting terminal. So how can you calculate the output voltage or the gain? So very simple, since the input impedance in between minus and plus terminal is infinity, as I just we discussed in the the ideal characteristic. So if infinite the resistance is infinity in between the inverting and non-inverting terminal, then no current will flow, and that is why if we made the ground to the inverting terminal, non-inverting terminal, then the same voltage, that is the V is equal to 0, will reflect at the non-inverting terminal. And so you can find out the current which is passing through the output to the the inverting non-inverting terminal. So that will be equal to the simply the V out minus 0 divided by R. Similarly, current in between the minus terminal and the VI will be the 0 minus VI divided by R1. So equate this and get the output voltage, that will be equal to the simply V1 into minus of R2 by R1. Similarly, we can also solve the inverting terminal, and here if we will solve, then we'll get the gain, that will be equal to the 1 plus R2 by R1. So here if we are giving the signals through the non-inverting terminal, then the output will be in the same phase, and the amplification factor will be 1 plus R2 by R1. Voltage follower, that will have the gain is equal to the 1, V out will be equal to V1, but still this is being used primarily for voltage follower inserted between the source and the load, which is being used to prevent the loading effects. So the primary job is to prevent it. That is, it will act as a buffer in between the source and the load. So you can check it here, like if there is the load, so if you are having the load, then the V out will be reduced and the gain will be the 0.01. So in order to remove this fact, we are using voltage follower having the gain is equal to 1 only. Now some more characteristics. So summing amplifier. So actually the operational amplifier can be used for any arithmetic operation, addition, subtraction, or integration, differentiator, anything. So here is the example of the addition, that is the summing amplifier. So suppose the three different voltages, input voltages V1, V11, V12 and V13 are there. So output will be the minus of Rf divided by R1 and addition of all the three input voltages, that is V11 plus V12 and V13. So how can we get it? So you can solve this equation. First find out the V output. If you are supplying the V11, that will be equal to the minus of Rf by R1 into V1. Similarly, you can find out the output voltage for VO2, VO for 1, V12 and VO for 1, V13, and then finally you can add it. Otherwise, you can also solve it like finding the current which is flowing through the V out and to the virtual ground, that is inverting terminal, and that will be equal to the current flowing through the all individual, that is the currents passing through the R1, R2 and R3. So addition of the current which is passing through R1, R2, R3 will be equal to the current which is passing through the RF as per the case given. Now, the another example is your differential amplifier. So similarly, the circuit is this being used as a difference or the subtractor circuit. So here the signals whatever you are applying V11 and V12 through the inverting and non-inverting terminal. So we'll get the output where we'll get the output of the difference of the two input voltage. So again, see here, and the operational amplifier circuit is there, differential amplifier with the V11, so you can solve it, and if you are supplying the VO1, then you can find out the output voltage, and in the case of the VO2 you can also find out the output voltage, which will be equal to 1 plus R2 by R1 into R4 by R3 divided by 1 plus R4 by I3 R3 into V12. So again, you can finally get output voltage is equal to R2 by R1 into V12 minus V1. So in short, the circuit is being used to subtract the any input voltages. So this is very simple to solve. Use the only three conditions. The first is that the make the resistance in between minus and plus terminal is must be infinity, and the voltage will be the since the resistance is infinity in between the minus and plus terminal, so the voltage will be same at the minus and plus terminal. And so find out the voltage at the plus, and that will be the same voltage at the minus terminal. And then if you know the voltage, that find out the current in between the 2 points, and then make it equal and get the values of the output voltage. So this is a simple way to find out. So try to solve some more problems on the operational amplifier, and let's move to the next session. So in the next session, we will talk about the open loop configurations, non-ideal effects in the operational amplifier, and the frequency response of the operational amplifier. So this is the one of the very important topics. So please try to solve some more questions. Thank you for solving. If you have any problem, you can drop a comments. Thank you.